last class we have seen how to find the inverse of a 2 by 2 and 3 by 3 matrices. Now let us verify the properties with the help of the problems which are given in our textbook. Now let us see first the example 1.8 given in the page number 10. Now in the material the problem is 21. Now it is given that A equal to 2197. For this matrix you have to verify this property. A transpose whole inverse is equal to A inverse whole transpose. That is the transpose and inverse are interchangeable. Now let us verify this result. First let us take the left hand side. Left hand side we have to take inverse for A transpose. Therefore first we can find A transpose. A transpose is equal to, we know very well, we have to interchange rows and columns of the matrix A. Therefore you can write it directly. First row can be written as first column. You can write 2 1. Then 9 7. Now this is A transpose. Now for this A transpose we need to find inverse, means you have to check whether A transpose is non-singular or not. For that we can find determinant of A transpose, which is equal to 2 7s are 14 minus 1 into 9. Now determinant A is equal to 14 minus 9 is equal to 5, which is not equal to 0. Hence we can say inverse of the transpose of A exists. Therefore we can find this inverse directly, or else first we can find adjoint, then we can go on to find the inverse. Therefore first we can find adjoint of A transpose. Adjoint of A transpose. This is A transpose. For this transpose I have to find adjoint, means since it is a 2 by 2 matrix, we can find adjoint of this 2 by 2 matrix as by interchanging leading elements 7 2. Change the sign of anti-diagonal minus 9 minus 1. Now we need to find the inverse for A transpose, means first of all we can recall this inverse of a matrix A equal to 1 by determinant A into adjoint A. Now this is inverse of A. Now we need to find inverse of A transpose, means just you replace A as A transpose. For that we can write A transpose whole inverse is equal to 1 by determinant of A transpose into adjoint of A transpose. Into adjoint of A transpose. Now after that just we can replace, yes, which is equal to A transpose whole inverse, which is equal to 1 by determinant A transpose equal to 5 into the adjoint of A transpose is 7 minus 9, then minus 1 2. Now we can have this as result number 1. Now we have found inverse for A transpose. Now we can go find the RHS, that is we have to find transpose for A inverse. For that first we can find A inverse. Want to find A inverse means we need to find determinant A value. If A is non-singular, A transpose is also non-singular. Now let us check, that is determinant A is equal to, for this matrix A we have to find determinant 2 7s are 14 minus 9 into 1 9, which is equal to 5, which is again not equal to 0. Hence we can say A inverse exists. Now for that we can find adjoint of A. Adjoint of A is equal to, now look at the matrix A. For this 2 by 2 matrix we need to find adjoint. Just interchange the lead elements as 7 2, then change the sign of anti-diagonal minus 1 minus 9. Now this is adjoint. Hence we can write A inverse is equal to 1 by determinant A into adjoint A into adjoint A. Now which is equal to 1 by determinant A, means 1 by determinant A is equal to 5 into adjoint A will be this one, 7 minus 1, then minus 9 2. Now this is A inverse. For this A inverse we need to take transpose, that is A inverse transpose, means this you can keep this 1 by 5 as it is. Now for this matrix, since it is a scalar you can keep as such, then you have to take transpose, means leave first row as first column 7 minus 1, second row as second column minus 9 2. Now you have This is equation number 2. Now look at equation number 1 and 2. 1 is what? A transpose whole inverse equal to 1 by 5 into 7 minus 9 minus 1 2. Then RHS A inverse whole is 1 by 5 into 7 minus 9 minus 1. Compare these two equations 1 and 2. Therefore we can say from 1 and 2 we can say RHS of these two results are equal, hence LHS will also be equal. Therefore, we can say A transpose whole inverse is equal to A inverse whole transpose. Hence, the result is true. Now we have verified. Okay. Now let us see the next problem. Now let us verify the next property. AB whole inverse equal to B inverse A inverse for the problem number 7 given at the page number 16. In the material it is problem number 15. The two matrices are given as capital A equal to 3 2 7 5, B equal to minus 1 minus 3 5 minus 2. Now for these two matrices I have to verify the result. Therefore first let us consider LHS. LHS means we need to find the inverse for the matrix AB. Therefore first we need to find the product AB. We can find the product AB is equal to 3 2 7 5. This is matrix A into matrix B is minus 1 minus 3 5 2. Now we can multiply by row by column method. 3 into minus 1 equal to minus 3, then plus 10, then here minus 9 plus 4, then this one minus 7 plus 25, then minus 21, then plus 2 5s are 10. Now if you simplify you can get the product AB as this is 7, this is minus 5, this is 18 and this is minus 11. Now this is AB. Now for this product AB we need to find inverse, means we have to check whether this AB is non-singular or not. For that we need to find determinant AB, which is equal to, first you multiply this to 7 into minus 7 minus 77, then minus of 18 into 5 gives minus 90, minus of minus 90 gives plus 19, which is equal to 13 and also not equal to 0. Hence we can say AB whole inverse exists. Therefore AB whole inverse is equal to, the formula is 1 by determinant of AB into adjoint of AB. Into adjoint of AB. Now this adjoint AB we can find directly, hence we can write AB whole inverse is equal to 1 by determinant of AB, which is equal to 13 into, we know very well how to find adjoint for this matrix AB, means interchange this leading diagonal. You can take minus 11, then you can take here 7, then 5, this is minus 18. Now this is AB whole inverse. You can have this as result number 1. The LHS part here completed. Next we can go for finding what B inverse into A inverse. For that first we can find A inverse, then we can find what B inverse. For finding A inverse, we need to find determinant A. Determinant A is equal to 3 5s are 15 minus 7 2s are 14, which is equal to 1, not equal to 0. Hence we can say A inverse exists. Therefore A inverse, the formula is 1 by determinant A into adjoint A. 1 by determinant A into adjoint A. Now this determinant A also we can find directly since it is a 2 by 2. Therefore 1 by determinant A. 1 by determinant A means 1 by 1, which is equal to 1. Therefore you can leave. Then you can write this 1 by 1 gives 1, therefore you need not write. Then you can write adjoint A, means A is here. Adjoint A can be found directly by interchanging these two elements. We can write 5, this is 3. Next we can change the sign, minus 2, then minus 7. This is A inverse. Then after finding A inverse, we need to find B inverse. We can find B inverse means we need to find determinant B. Determinant B means for this one minus 2, then minus 5 into minus 3 minus 15, minus of minus 15 gives a plus 15, which is equal to 13. This is also not equal to 0. Hence B inverse exists. For that we can write B inverse is equal to 1 by determinant B into adjoint B. Now we can write B inverse is equal to 1 by determinant B means 1 by 13 into adjoint B means we can consider matrix B. We can interchange these two. This is 2 minus 1, then 3, this is minus 5. Interchange these two, change the sign of these things. Now this is B inverse. Then after finding A inverse and B inverse, we need to multiply them in reverse order. Therefore we can go for the next one. Next step, B inverse into A inverse. First we can find B inverse. What is B inverse? 1 by 13 into 2, 3, then minus 5 minus 1 into A inverse is 5 minus 2, 5 minus 2 minus 7, 3, minus 7, 3. Now which is equal to 1 by 13 you can keep as it is, you not disturb. Then you can go row by column, 2 5s are 10, then minus 21, then you can go for this one, 2 into minus 2 minus 4, then plus 3 3s are 9, then second row first column minus 25, then plus 7 you can say, then you can take a plus 10, then minus 3. Now after that try to simplify, then you can get B inverse into A inverse as 1 by 13 into, this is minus 11, this is 5, this is minus 18 and this is 7. Now you can take this as result number 2. So compare the results 1 and 2. The result 1 is AB whole inverse equal to 1 by 13, this is 1 by 13, minus 11, 5, then minus 18, 7. Now the RHS of these two results are equal, hence we can say LHS are also equal. Therefore we can say from the results 1 and 2, we can say AB whole inverse is equal to B inverse into A inverse. Now we can say the results holds good. Okay, now likewise you can verify the other problem, that is problem number, you can say example 1.9, example 1.9 which is given in the problem number 11 and our material the problem number 15. This you can practice in the same way. Now likewise I have given one more extra sum. You can see problem number 16 even in the material. That is not given in your book, just I have given for your practice. Therefore you after copying these things try to do these two problems. Okay. Now let us see the next problem. Problem number 3. Problem number 3 given at the page number 15 in the first exercise, and the same problem is given in the material 3. Third problem. Now for this matrix f of alpha is given. It is a 3 by 3 matrix. It is given as cos alpha 0. Then you can write sin alpha. Then 0 1 0. The next row is minus sin alpha 0. Then you can write cos alpha. Now for this matrix f of alpha, we have to show that f of alpha whole inverse which is equal to f of minus alpha. F of alpha whole inverse is equal to f of minus alpha. Now this is the third problem in the material also. Now for this given matrix you have to show that result. Show that LHS is equal to RHS. Now we can take This LHS, f of alpha means we need to find determinant of this f of alpha. You have to check whether it is non-singular or not. Therefore, we can find determinant of f of alpha, which is equal to. For this, you can take the, since it is a 3 by 3, you can take first plus minus plus. Like that, you can write cos alpha into 1 into cos alpha, then minus 0, then minus 0 into another minor, then becomes 0 only. Therefore, we can leave it minus 0, then plus, I can go for this one, sin alpha into, leave this one, this column, 0 minus sin alpha into minus sin alpha, minus of minus becomes plus, you can write sin alpha. Now, which is equal to cos alpha minus 0 equal to cos alpha into cos alpha, cos square alpha. Then this vanishes. Then you can take 0 plus sin alpha equal to sin alpha into sin alpha plus sin square alpha, which is equal to 1. Now we can say determinant of f of alpha is equal to 1. We can say which is not equal to 0. Hence, f of alpha whole inverse exists. For that, since it is a 3 by 3 matrix, we have to find what adjoint first. Therefore, we can find a adjoint of this matrix. Adjoint of f of alpha, which is equal to, here also we can put 9 brackets. First bracket, then second bracket, then third bracket. For second row, this is for the third row, for this whole transpose. As I told, this plus minus, then you can put a minus here, then minus here, then minus here. Just you compass, take this one. Okay. Or else you can put alternatively plus sign and minus sign. Okay, now here, first one, you can take this one. This you can get what cos alpha. Then second one is, leave this one, leave this row and this column, can get 0 minus 0 gives what 0 only. Then for this one, you can write sin alpha. That is, leave this row, this column, 0 minus of sin alpha plus sin alpha. Now for this one 0, you have to leave this row and this column, this 0 minus 0 gives what 0 only. Next, for this element, leave this row and this column, cos square alpha minus of minus plus sin square alpha. Cos square alpha, can write cos square alpha plus sin square alpha here. Then for this one, leave this row, this column, 0 minus 0 gives 0 only. Okay, now next for this element, leave this row, this column, this is 0 minus sin alpha, minus sin alpha. Now for this element, leave this row, this column, 0 minus 0 gives 0 only. Now for this element, cos alpha minus 0 gives cos alpha. Now after that, we can take adjoint of f of alpha, which is equal to, first this is cos alpha, this is 0, then sin alpha, then 0. Since cos square alpha plus sin square alpha equal to 1, you can write 1. Then this is 0. Then this is minus sin alpha. Then this is 0. The next one is cos alpha. Now for this, we need to take transpose. Please don't forget to take transpose. Now adjoint of f of alpha is equal to, take transpose, make interchange rows and columns. You can write first cos alpha 0 sin alpha, then second row, second column 1 0 1 0, then third row is third column minus sin alpha, then 0, you can write cos alpha. Now this is adjoint of f of alpha. Hence we can write inverse of f of alpha. That is f of alpha whole inverse is equal to, 1 by determinant of f of alpha into adjoint of f of alpha. Now is equal to f of alpha whole inverse is equal to 1 by f of alpha means f of determinant of f of alpha equal to 1. Therefore 1 by 1 gives 1, therefore you cannot write. Then we can write directly adjoint of f of alpha, that is cos alpha 0 minus sin alpha. Then you can write 0 1 0. Next we can write sin alpha 0 into cos alpha. Now this is f of alpha whole inverse. Now we can take this as result number 1. Result number 1. Now we have found the LHS. Next we can see what is f of minus alpha. It is given that f of alpha equal to cos alpha 0 sin alpha 0 1 0, then some minus sin alpha 0 cos alpha. Now we need to find f of minus alpha means wherever you find alpha, that is to be replaced as minus alpha. That is a cos of minus alpha 0 sin of minus alpha. Then this is 0 1 0. This is minus sin of minus alpha, then 0, this is cos of minus alpha. Now for that we can say f of minus alpha is equal to, see we know very well cos of minus theta equal to cos theta, therefore we can write cos alpha. Cos of minus alpha equal to cos alpha, this is 0. We know very well sin of minus theta equal to minus sin theta, hence sin of minus alpha equal to minus sin alpha. Next row we can write 0 1 0. Next one we know very well sin of minus alpha equal to minus sin alpha, minus of minus becomes plus sin alpha, then this is 0. Cos of minus alpha is equal to cos alpha. Now we can have it as result number 2. Yes. Now want to find f of minus alpha means without writing this step you can write this step directly. You will not write this step. Okay. Now after finding f of minus alpha we can verify the results 1 and 2. See 1 and 2 gives what? The same result in the right hand side. Hence we can say from 1 and 2 we can say f of alpha whole inverse is equal to f of minus alpha. F of minus alpha. Hence we have proved the given result. Okay. Yes. Yes. Now let us prove this small theorem. If A is a non-singular of odd order, then we have to prove that determinant of adjoint A is positive. For that here it is given that you can go for proof. See here, n is an odd number, that is n is equal to odd number. Yes, odd order given. Therefore, let us take n is equal to 2k plus 1, where k equal to 0, 1, 2, 3, etc. Whatever be the value of k, if you multiply by 2, you can get an even number. If you add 1 with this even number, you can get an odd number. Therefore, for our convenience, we are taking n equal to 2k plus 1, which is which number now? Odd number. N is an odd number. Now, after that, by the property, there is we know that determinant of adjoint A, already we have seen, determinant A power n minus 1. Now which is equal to determinant A power, instead of n what we have 2k plus 1, then instead of n we have equals 2k plus 1, then we can write minus 1, which is equal to determinant A power my plus 1 minus getting cancelled, can get 2k. Now whatever be the value of this determinant A, whether it is negative or positive, the power is an even number, means you can get only positive number. Therefore, it is a positive quantity. Hence we can say adjoint of A is a what? A positive quantity. That's all. Now with this we can stop this class. Now in the next class we will see few problems which are left out in the first exercise. Please work it out all these problems and practice yourself. Then if you have any doubt you can ask me. Okay. Now we have completed few problems in the exercise. The rest of the problems we will see in the next class. Okay. Please work out all these problems. Then if you have any doubt you can call me. Okay. You have to put a separate notebook and you have to work it out all those things. Then we will see in the next class. Thank you, children.